In this video presentation, I'm going to show the workflow feature of Harmony. The workflow feature is useful when you have an analysis that is quite complex and has some very specific sequence of analyses that are useful in a very specific instance. In this particular case, we're going to look at a Haynesville example. Now in the Haynesville, we have some very specific considerations that we need to use that maybe aren't applicable in all other places. For example, geomechanical model is very commonly used in the Haynesville because we believe we have a pressure-dependent permeability and formation compressibility that is actively influencing the well performance. So when we go and look at the analysis for the Haynesville, we have a very specific sequence of analysis methods that we find useful in analyzing the data. And this sequence is not necessarily something that we would use in other plays, so it's very specific utilization. So we're going to start by looking at the flow regimes, and it shows that the data is in boundary-dominated flow. And then we do an original gas in place estimate. Now what's unique about the Haynesville is that very often we have shut-in pressure data where we can compare the flowing analysis to the shut-in analysis. And this invariably yields a very strong diagnostic of a decreasing productivity index. We've seen this time and again in the Haynesville. Doing a simple forecast, we can come up with an estimate of recoverable reserves. But in the Haynesville, we've done some fairly complex history match modeling using this geomechanical model. And you can see I've done one here without using the pressure-dependent permeability. And then we've done another one here using the pressure-dependent permeability. And what we found is that the only way to match the production data is to use the pressure-dependent permeability model. Otherwise, you cannot get a consistent match between the drawdown and the buildup. So once we've finished with this whole sequence of analyses, we can then do a forecast comparison. We can take a look at what the simple forecast looks like and compare it to the analytical model. Sorry, analytical model with KP is what we want to use. And we can see they compare quite nicely. We've gained a lot of knowledge and experience through going through this workflow and all of these steps. So what we'd like to do is capture that in the Harmony application and be able to apply that same workflow to new wells that we haven't looked at yet. In order to do that, we can use this button, which is Add to Workflow. So I'm going to create a new workflow, and I'm going to call it Haynesville. I'm going to hit OK. I can save that workflow. And now when I analyze a new Haynesville well, at first I have all the analysis methods open to me. But what I can do is go in here and select that Haynesville workflow. And all of the tabs that I created during that last analysis procedure have now been deployed in exactly the same order with the same naming conventions that I used before. So this will guide me to make sure that I do a systematic analysis that's tailored specifically to the field that I'm working in and has all the right analysis methods, all the same sort of analysis methods that are useful for that particular field.